This is 2022 IMO problem number 1. Here we are given a sequence of coins of 2 different types. We're given integer k. Here, 2 coins both have n numbers, right? A and B type. And then, when they same type connecting with each other, we call that a chain. Now here we're saying that the rule of the game is actually you always pick the k and the chain is associated with and move that to the front of the sequence, and you keep going until you end up with coins of same type sticking together. In other words, n coin A followed by n coin B, or vice versa. Of course, you may end up with a looping condition where you're never going to reach this state, right? So here we are asked to figure out what is the combination of n and k, positive integer here, such that no matter how the initial condition is, you can always terminate. In other words, you always end up with either n type A followed by n type B, or n type B followed by n type A, right? So why don't you read the problem, pause the video if needed, and try to solve it. When you are ready, let's continue with the solution. All right, first, we're going to look at some example run. All right, so here we marked n equal 5, the total 10 coins, 5A, 5Bs, but the shuffled in the initial condition here, k equal to 5 in this case, and I mark it here, and every time the chain is going to move to the front of the sequence, and then you continue the process. In the step number 2, the chain only be by itself, you move to the front, and here you're gonna have, you're leaving this 2A and 3A together. You have 5A in a row. When you move, then you're done, because 5A followed by 5B. That's good. Terminating condition. All right. So that's a success run. Now in this case is a failed run. All right. So what happens is, in this case, n equal to 6, k equal 11. The total is like 2n would be 12. So you have 12 coins, and the initial condition is here. Here we follow the rules, and then notice that at the end you end up with the initial condition. In other words, you are looping here forever, right? So it will never terminate, right? So here we would like to see what kind of combination that allows us to terminate, right? What is kind of n and k, right? Positive integers, right? So let's do that. Now we're going to introduce some notation. Here we, chain as defined as a, a sequence run of the same type. So I'm going to keep track of the chain count. How many chains do we have in the sequence? All right. C sub A is the number of chains of coin A. C sub B is for coin B. The total would be the summation of it, right? So here, I'm going to keep track as we play the game step by step. So the T here would be different step, and we start from 0 with the initial step T equal to 0, right? So let's look at, with this notation, let's look at our examples in the successful run. So let's keep track of what is a CA, what is a CB at different times. This is time, yeah, the time 0, 1, 2, 3, and what is the total C, right? So here, of course, by definition, is the CA is the type A here, 1, 2, 3. So CA is 3, 3B here is going to be 1, 2, and 3. So the total is 6. Now the next time, I have 2, B is 1, 2, and 3. So I have 5 total. And A, okay, big chunk here, that's good. Okay, is 1. And B here is 2. So the total is 3. And here's 1 and 1. 1 and 1 and 2. All right, notice that with our notation, if it's successful, it's going to be, the ending count is going to be 2. That's the good condition, right? And also notice that as time goes by, this count decreases. That's good news. And then that where you can terminate. Yeah, but let's look at the failed one. So what is the CA, CB? What is the total? What is the time here? 0, 1, 2, 3, and 4. So here, let's count. 1, 2 is the CA is 2, 1, 2, CB is 2. The total is 4. And here, 1, 2, 1, 2, so it's 2, 2 is 4. And here is 1, 2, or 2, B is 1, 2, 2, 2. Oh, it never changes, no wonder. A is 1, 2, B is 1, 2, 2, 2, 4. Here's again, A is 1, 2, 2, 2, 4. This is always a constant. All right, this is what we noticed. All right, so that's good. So at least we notice some pattern here. Continue. So the question is, when will it change and when the count does not change from the current step to the next one? All right, this is a big question. All right, so once we answer this question, we're going to have a clue of how to solve this problem. All right, so I claim that if the case position is sandwiched by different type, then the C always decreases. What do I mean by sandwich of different type? Now remember, the rule of the game is that case position you have to move to the front, right? So case position, I think without loss of generality, we're going to say is A, right? So let's say it's A. You may have labels. You're going to move the whole chain. Yeah, this is A, this is A, to the front of the chain of the sequence, right? This is the front. Yes, something at the front, and then this is the end, right? So here by sandwich, I mean it has something on the right, it has something on the left. Of course, there must be type B, because why? If there are A, there must be considered as one sequence here, right? So this is called sandwich. In other words, if there is on both ends, is sandwiched by what? By opposite type. Opposite type. Now, why I claim that is always decreases. All right. Okay. Let's look at it. In this case, we're gonna look at two cases. What is type at the front? The chain type in the front, right? So case one, because I moved to the front, right? The front is A. Case 2, the front is B. So what will happen of the CA and CB in both cases? We can look at that, right? So here, because you moved, let's use a different color here, right? So you move this chain out, which means you're connecting B. So the number of chains for B would decrease because of that move, and this is true in both cases, right? So I'm using the programming language, minus minus meaning decrease by 1, right? Or we can say minus equal 1, right? Meaning the decrease by 1. Now, if you move to the front, but the front is A, you're merging two chains again. So CA in this case is going to decrease by 1, right? Or minus equal to 1. And if the front is B, yeah, and you move A in front of it, nothing changes. The count does not change. So here, so for two cases, but no matter what, as long as it's sandwiches, the total C in this case decreased by 2, in this case decreased by 1. So the claim is that CT decreases with S if case position is sandwiched by opposite type. That's good. All right. So Then on the looping condition can only happen when the case position is at the end, right? Because if not, it always decreases, right? So we try to see when it will loop forever, right? So is either case position on the front or at the end, right? That's what we learn. All right, that's good. So let's look at both cases. Looping condition on the left hand side. So imagine I have a sequence here. This case position is on the left, and it's going to loop, which means that up to k, everything must be the same type. Again, assume this case position is A. Here you must have all A's, because if not, you're going to change in the, you have different type, you can create like sandwich situation. All right, so that's easy. All right, so I claim that if k is smaller than n, we can always create an initial sequence for looping condition on the left end. Yeah, that's very easy. Yeah, so if I given n, it is total 2n, right? N coins here. What I can do is I can make all the k, this is k, of the same type. A. The next one must be a B, right? The next one must be a B. Yeah. So when the case position is anywhere in here, when you move, nothing changes, right? The change because the rule says this is case position. You move to the front, not the whole sequence is unchanged. Now, if k greater or equal to n, then you cannot create this sequence. You cannot. Why? If k crosses the boundary of n, right? Let's erase it here. So this is n here. If k, let's say, is n, right? The nth position. Okay. Now remember, everything must be the same type, right? But then if everything is A, we're done, right? Because the remaining would be B. You have n A's and B's. Now, if a different type, then you're going to mix up, and then it's not going to be the looping condition, all right? So now the question is, what if k goes too far? What will happen? Then you'll enter what is called the right end looping condition, right? So on the left end, you must have this. You can always create, looping condition. So our answer should exclude this condition, right? Because we're looking for the combination of k and n such that we can terminate, right? And here, for sure that with this is always looping. Okay, now at the right end, what will happen? Yeah, so let's look at that. So assuming I have a sequence here, n, and another n, I want to create a situation on the right. So k is somewhere here. This is my k position. Yeah. So again, assuming as k's position is A, the analysis will be the same. If otherwise, right? A. Yeah. If it is sandwiched, then it's the decrease, so it's not sandwiched. In other words, everything until the tail is all A's. Yeah, this is the tail. Yeah, same type. And in front of it must be B, right? Otherwise, it's be merged into A sequence, right? So let's say you're gonna move the whole chunk to the left. In other words, you're gonna have A in the next time. You have 4 A's here, right? And B is going to be at the end. B maybe is shorter or longer, right? B is going to be here. This is going to be B, 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 and something like that, right? Assuming now, if the original is A, you're going to make A merge into a longer sequence, right? And then this is something that you're going to change the situation. It will not loop again, because when you when you keep going, this whole chain is pushed to the right, and then it's going to terminate, eventually, because in order to stuck in this condition here, you always want to have alternating sequence, right? Because this is merging here, your count of CA decreases, because we're looking for the case where the CA remain the same. So which means it requires that when you move this chunk here, this must be B from the original sequence. This is B. All right, and also, if in the next stage, right, in the next time, you would imagine, because this here B is going to be moving to the front. However, if there's some tiny chunk here, let's say at some time t here, if somehow at this position I have a mixed, what if this is A here, what is A is very short, there's only two A's and a bunch of B's, right? So what will happen? Let's look at that. So imagine you have two A's here, yeah, and then you have B and B. Now this happens that you create a case where when you move, it's sandwiched by A. You don't want to do that, because if that sandwich situation is created, the count is going to decrease. We're looking for looping condition. Looping condition means what? CA does not change, CB does not change, C does not change. So in order for that to happen, your tail that you're going to move, yeah, must be that no matter what type of coin chain you're going to push the tail, this is K, make sure it's always at the tail of the same type. You're not going to create this sandwich situation, right? So this is a summary. So in order to have a looping condition on the right, the tail must be small enough. Yeah, the tail cannot be too big. Okay, if the tail is too big, like for example, if K is here, the tail is very big, then you're going to create a situation that the type is going to be mixed. Whenever you have a mixed type, you're going to create a situation where the case position is sandwiched. When case position is sandwiched, the total count C will decrease. All right. So the tail length, of course, what is the tail length? Let's think about it, right? So total we have 2n object. This is case position. We're gonna create a tail situation. This is case position and all the same type. Yeah. And there must be k minus 1 object here, right? So the tail is going to be 2n, the tail length here is going to be 2n minus k minus 1, so which is 2n minus k plus 1. And the sequence must be chain of alternating types, right? It's like A followed by B followed by A followed by B and things like that, right? And the tail length cannot exceed the minimum of all chain lengths, right? So for example, earlier we say if the minimum is 2, your tail length cannot be more than 2, because if the tail length is more than 2, you're going to create a situation where you're going to be sandwiched at case position, right? So that is the case. Under these 4 conditions, which means K must be big enough, right? So that whatever alternating sequence here, the tail, which is 2n minus k plus 1, must be greater or equal to the minimum of the chain length in the sequence. Yeah, let's look at the example. So in this example, earlier we say is looping, it's right and looping, right? So what is the chain length? This is 3, this is 2, this is 3, this is 4. So chain length is 2. What is the tail length? Tail length is 2, right? Because k equal 11, n equals 6, So 2n minus k plus 1, that is the tail length. And in this case is 12 minus k is 11 minus 11 plus 1, tail length is equal to 2, right? And the minimum of the chain length equal to 2, right? They're equal to each other. That's good. If k is greater than the minimum, in other words, if the position is here, yeah, if position is here, I claim that it will not loop forever, because think about it, right? Everything, if you move, you push, when you push BB to the end, you're gonna create a situation that you're gonna have BB as n, but then you have A as k's position, which is a sandwich situation, and the C will decrease. All right. So in summary, k, in order to be good, must be in this range. When k is very small, you're gonna have left end looping condition. When k is big enough, in other words, tail is small enough, you're gonna create a right end looping condition. All right. So that's the analysis of the problem, and hope you enjoy this process and try to think about the steps of the reasoning. And please, share, like, and subscribe to the channel. Thank you.